Hi guys, today we're going to be doing further maths paper 21 for October-November 2023. So we're going to start with the first question. It says that the system of equations does not have a unique solution and we need to find the value of k to meet this requirement. So we can first write these equations into a matrix. So you get 14, -4, 6, 1, 1, k, and -21, 6, and -9. So when it says that the system of equations does not have a unique solution, it means that the determinant of the matrix is 0. So we just need to prove that. So to find the determinant, we take 14 times this matrix plus 4 times 1k, -21, -9 plus 6, 1, 1, -21, and 6. So basically, when you take 14, you cover up this row and this column, and this will be the matrix that you have to put here. And for -4, because the symbol is plus, minus, plus, so minus minus 4, you get +4, and you cover up this row and this column. So this will be the matrix here. And for 6, you cover up this row and this column, and this will be the matrix here. Okay, so now we just take 14 times -9 minus 6k plus 4 times -9 plus 21k plus 6 times 6 plus 21. So you take this, you times this together minus the product of these two, like this and like this. And you will get -126 minus 84k minus 36 plus 84k plus 36 plus 126. And the answer will be 0. So we have proven that the determinant of the matrix is 0, and therefore it does not have a unique solution. So now we have to interpret the situation geometrically. So we just look at the equations, and you can see that for the first equation, if you divide it by 7, you will get divide it by 2, and you will get 7x minus 2y plus 3z equals to 5 over 2. And for the last equation, if you divide it by -3, you will get, hang on, let me just move it over. You will get 7x minus 2y plus 3z equals to -14 over 3. So you can see that these two equations are similar. They are just scalar multiples of each other. So you can say that these two planes are parallel. Why are they parallel but not the same plane? You see the last figure. If they are not the same, but the front part is, then there are parallel planes. Okay, so now we can say that there are two parallel planes and they are not identical. and we have another plane that is not parallel. And that's it. For the second question, we need to solve this equation given in the form of this cos and sine. So we can first start with changing this into the format of r exponential to the power of I theta. Alright, so r can be found using this 4 square plus 4 sub 3 square the whole thing and square root the whole thing. This will be 8, and theta can be found using arctangent 4 sub 3 over 4, and this will be pi over 3. And why is it pi over 3 but not 2 pi over 3 or 4 pi over 3 or even 5 pi over 3? We can draw this out. This is the imaginary axis and this is the real axis. And 4 plus 4 sub 3i is around here. So this is the real axis and this will be the imaginary. This will be 4 plus 4 sub 3i. So you can see that the angle here is pi over 3 instead of 2 pi over 3, 4 pi over 3, or 5 pi over 3. So yes, this will be our theta. And now we can start solving the equation. So z plus 5i to the power of 3 equals to 8 exponential to the power of pi over 3i. And we can write this as 8 times exponential to the pi over 3 plus 2k pi I. So why do we need this extra 2k pi? So, oh wait, I forgot to write this. Where k equals to 0, 1, and 2. Because we have three answers, right? So we just have to write it until 2. So why is this 2k pi here? So let's say when k equals to 0, you get 8 times e to the pi over 3i. And when k times 1, you basically get 8 times 3 to the pi over 3 plus 2 pi I. That means it was originally here, and now you plus 2 pi. That means you will rotate for one round and go back to the original position. That means you will still get this figure here. But when you solve for this, you solve for the root, then you will get different answers. Because you have 3 roots, you will need k equals to 0, 1, and 2 to get 3 different answers. If you didn't add this, you will only end up getting one answer for z. Okay, we will continue now. So z plus 5i equals, so you will cube root this whole thing. Alright? So the cube root of 8 is 2. And cube root of the exponential part is just the power times 1 over 3. So you will get pi over 9 plus 2k pi over 3I. Same thing, where k equals to 0, 1, and 2. So the first root for z plus 5I, now we can change it back to this form. So to change it back to this form, this r here, this r's here are just this number, and the thetas here will be this one, will be the angle here. So first one will be 2 times cos pi over 9 plus I sine pi over 9, and the first root would be 2 cos pi over 9 plus the imaginary part, which is 2 sine pi over 9 minus 5. Minus 5 is basically you move this to this side. So this will be the first root. Second root, z plus 5I equals to 2 times cos 13 pi over 9. Oh, sorry. 7 will go first. 7 pi over 9 plus I sine 7 pi over 9. So the second root would be 2 cos 7 over 9 plus I 2 sine 7 pi over 9 minus 5. And for the third one, you get z plus 5I equals to 2 times cos 13 pi over 9 plus I sine 13 pi over 9, and the third root would be 2 cos 13 pi over 9 plus I times 2 sine 13 pi over 9 minus 5. So if you're wondering how I get all these angles, this is basically when k equals to 0, this is when k is equals to 1, and this is when k is equals to 2. And that's it. For the third question, we will need to find the first three terms in the Maclaurin series for octang half e to the power of x in the form of this. So in the formula booklet, it's given this equation. So if we need up to the x squared term, we will need to find for the second derivative of fx. So we can first write fx equals to octang half e to the x, and now we need to find the first derivative. So this is not given in the formula booklet, but I can show it to you guys. So I'll use black. Okay. The derivative of octang fx is f prime x over 1 minus the square of fx. So we can let y equals to arctan fx, and now fx will be tan y. So tan y, you can find the differentiation here. So this one would be sec square y. Sec square y dy dx. Because we are differentiating in terms of x. So now dy dx would be f prime x over sec square y. And now sec square y is, look at this. We have cos square minus sine square equals to 1. And if you divide this equation by cos square x, you will get this equation, which is 1 minus tan square x equals to sec square x. And now we know that sec square x is 1 minus tan square x. So we can write this as f prime x over 1 minus tan square y. And now we know that tan y is actually fx. So we can also write it as f prime x over 1 minus f x squared. Alright, so this is the proof. We'll put it aside. And now we will start differentiating fx. So fx, okay, so the half e to the x is actually the fx in this case. So we will factorize half e to the x, which is also half e to the x. So over 1 minus the square of this. So it's 1/4 of ex. Oh, sorry. E to the 2x. Yes. So for the second derivative, it would be 1 minus 1/4 e to the 2x times half e to the x minus half e to the x times negative 1/2 e to the 2x, and the whole thing will be divided by 1 minus 1/4 of e to the 2x, square the whole thing. So now f0, which is basically arctan 1/2. So this is also not found in the formula booklet, but I can prove it to you guys. So arctan x is actually half of ln 1 plus x over 1 minus x. So to prove it, we first let y equals to arctan x, and x will be tan y. And now you can write this as e to the y minus e to the negative y over e to the y plus e to the negative y. And you move the denominator to the left side, so x times e to the y plus e to the negative y equals to e to the y minus e to the negative y. And now you times the whole equation by e to the y, so you get x times e to the 2y plus 1 equals to e to the 2y minus 1. And you group the e to the 2y together, so you get x minus 1, and the other side would be minus x minus 1. And now e to the 2y equals to, let's make it nicer, so 1 plus x over 1 minus x. So 2y is equals to ln 1 plus x over 1 minus x. So y is equals to half of ln 1 plus x and 1 minus x. So this will be the proof. I'll put it here. F0 is half ln 1 plus half over 1 minus half. And this will be half ln 3. So f prime 0 is half over 1 minus 1 quarter from here, right? So this will be equals to 2/3. And f prime prime 0, you will get 1 minus 1/4 times half minus half times negative half over 1 minus 1/4 square, and this will be 10 over 9. So you can now write the arctan of half e to the x as 1 over 2 ln 3. You just write it according to this formula. So f0 is 1 over 2 ln 3, and for the second term, you will get x times f prime 0, which is 2 over 3 plus third term, you will get x squared to the 2 factorial times f prime prime 0, which is 10 over 9. And now you will get the final one as half ln 3 plus 2/3 of x plus 5 over 9x squared. Question 4 is about differential equation. So this is a second order differential equation, and we would split it into a few steps. First step, we write this part into m squared plus 2m plus 3 equals to 0. And we solve for m. So m is negative 2 plus minus 2 squared minus 4 times 1 times 3, square root the whole thing, 2 times 1. So the answer would be negative 1 plus minus sec 2i. So when m is not a rational sorry, not a real number, we write the complementary function in this format. A cos sec 2x plus b sine sec 2x times x to the power of negative x. And how do I get that? It's basically for the negative 1 in the real axis, I put it in here, the power of ex. And for the imaginary number, I put it here at the cosine and sine part. So we will get this general form of the complementary function, and we will find for a and b later. So now we will go to part 2. We have the particular integral, which we can write it as y equals to, okay, for this one, we have to look at this part. So we have x squared, so the highest degree for the polynomial is 2, and we have to write our particular integral as y equals to ax squared plus bx plus c. So the highest degree of x is also 2. If this is 27x cubed, then we will write it as ax cubed plus bx squared plus cx plus d. Okay? So take note that even though there's no x and constant in this equation, we still need to write these two out. We cannot just ignore them. So now we differentiate y and get 2ax plus b. And we differentiate it again, and we will get 2a. Now we go to the third step, which is basically we sub all of this into this part. So we get 2a plus 2 times 2ax plus b plus 3 times ax squared plus bx plus c. So this is basically, this one is d2y over dx squared. This part, sorry, this whole thing. And this part is our dy over dx. And this part is our y. So after subbing in, don't forget our 27x squared. And now we can find for a, b, and c. So this part we just compare the coefficient. So the coefficient of x squared is 3a equals to 27, and we get a equals to 9. Now we can find for b. So the coefficient of x is 4a plus 3b equals to 0. And a is 9, so b is negative 12 in this case. And now we compare the constants. So 2a plus 2b plus 3c equals to 0. 2a plus 2b plus 3c equals to 0. So again, a is 9, b is negative 12, and we get c equals to 2. So now we can write the particular integral as y equals to 9x squared minus 12x plus 2. And for the fourth part, we write the whole equation. So y is actually the complementary function plus the particular integral, and we get a cos sec 2x plus b sine sec 2x times e to the negative x plus 9x squared minus 12x plus 2. And now we have to differentiate it. So we differentiate it to get a cos sec 2x plus b sine sec 2x times negative e to the negative x plus negative sec 2a sine sec 2x plus sec 2b cos sec 2x times e to the negative x plus 18x minus 12. And now we can simplify this to e to the power of negative x times bracket negative a plus sec 2b times cos sec 2x plus negative b minus sec 2a times sine sec 2x plus 18x minus 12. And now we can sub these figures. So x equals 0, y equals 2. When x equals to 0, y equals to 2, and from this equation, we can get 2 equals to a cos 0, and sine 0 is 0, so we don't have to care about that, times e to the 0, and 9x squared minus 12x will be 0, so we just write plus 2. So a will be 0. And dy dx equals to 8 when x is 0. When x equals to 0, dy dx is negative 8. So we look at this equation, and we get negative 8 equals to e to the 0 times, okay, so a is 0, so we only have sec 2b cos 0, and sine 0 is 0, so we don't have to care about this whole thing, and 18x is also 0, so we are left with negative 12. So now sec 2b will be 4, and b would be 2 sec 2. And the final equation, we just sub the capital A and capital B back. So 2 sec 2 e negative x sine sec 2x plus 9x squared minus 12x plus 2. And we're done. For question 5a, we need the exact length of C, and C has the parametric equations of x equals to 2 third of t to the 3 over 2 minus 2t to the power of 1 over 2, and y is equals to 2t plus 5. So firstly, we will need to find the dx over dt. So it will be t to the 1 over 2 minus t to the negative 1 over 2. And dy dt will be just 2. And now the exact length of c, let's call it s, it would be the integral of 0 to 3 as given here. The integral of 0 to 3 for dx over dt squared plus dy over dt squared over, sorry, not over, square root the whole thing. So we just sub whatever we have found just now. So t to the 1 over 2 minus t to the negative 1 over 2 squared plus 2 squared. Square root the whole thing. And now we have t minus 2 plus t plus 4 square root dt. Sorry, this is t to the negative 1. Yes. So now we have t plus 2 plus t to the negative 1 square root the whole thing. And we can factorize this as t to the half plus t to the negative half square and square root the whole thing. And now this will be much easier, which is just t to the 1 over 2 plus t to the negative 1 over 2. And now we can just integrate it. We get two over 3 times t to the 3 over 2 plus 2t to the 1 over 2. And then we sub t equal to 3. And t equals 0, you basically just get 0. So this would be 2 sub 3 plus 2 sub 3. And the final answer would be 4 sub 3. For part B, we need to find the set of values of t for which d2y over dx squared is more than 0. So first we will need to find dy over dx. And it's basically dy over dt times dt over dx. So let's just copy what we have found just now. So dy over dt is t to the half minus t to the negative half, and dt over dx, oh sorry, dy over dt is 2, and dt over dx is 1 over this whole thing. So 1 over sub t minus 1 over sub t. So you will get 2 times sub t over t minus 1. And the final answer would be 2 sub t over t minus 1. And now you can find for d2y over dx squared. And this is basically the derivative of dy dx times dt dx again. So you just have to differentiate this one more time, times dx dt. Sorry, times dt dx. So you differentiate this again, and you will get, use the quotient rule, t minus 1 times t to the negative half minus 2 sub t over t minus 1 squared times sec t over t minus 1. And you would get t minus 1 minus 2t. I move the sec t down here times sec t over t minus 1. And now these two can be cancelled off and we get negative bracket t plus 1 over t minus 1 to the power of 3. So this will be the d2y dx squared, d2y over dx squared. And now we need to find the set of values for which this whole thing is more than 0. So we get negative t plus 1 over t minus 1 to the power of 3 more than 0. We get rid of the negative sign, so we get t plus 1 over t minus 1 cubed less than 0. So, to let it be less than 0, we either have t plus 1 less than 0 and t minus 1 cubed more than 0, or we get t plus 1 more than 0 and t minus 1 cubed less than 0. So to get t plus 1 less than 0, we have t less than negative 1. And in this case, we have t minus 1 more than 0 and t more than 1. So we can draw a number line. This is negative 1 and this is 1. T less than negative 1 is here, this part. T more than 1 is this part over here. And you can see that there are no intersection of both inequalities. And since we need both to be true to get this, we have no solution if we set t plus 1 less than 0 and t minus 1 cubed more than 0. So we go to the next part. For t plus 1 more than 0, we get t more than negative 1. And for t minus 1 cubed less than 0, we get t less than 1. And we draw the number line again. This is minus 1 and this is 1. T more than negative 1 is here. T less than negative 1 is here. So you can see that there's a intersection here. This part is when both of these inequalities are true. So we can say that negative 1 is less than t and t is less than 1. So t will be in between negative 1 and 1. But in the question itself, it is said that t is in between 0 and 3. So we cannot have t equals to negative 1. Sorry, we cannot have t less than 0 and more than negative 1. So we can only write it as t is more than 0 and less than 1. So this will be the final answer. For question 6, starting from the definitions of cosh and sine, we need to prove this equation. So let's just write out what cosh x and sine x are. So cos x is e to the x plus e to the negative x over 2, and sin x is e to the x minus e to the negative x over 2. So we can start from the right hand side. The right hand side says that 2 sin x cos x. And we can plug the exponentials in. So e to the x minus e to the negative x over 2 times e to the x plus e to the negative x over 2. And now we have half. And take note that this is basically the difference of square. So we get e to the 2x minus e to the negative 2x. And this is basically sin 2x, which is also the left hand side that it's given. So we have done proving this. Part B, we need to use the substitution of u equals to sin x to find the integration. So u equals to sin x. So du over dx is cos x, and dx would be 1 over cos x times du. So now the integration, we have sin square 2x times cos x, and it's equals to, we can change sin 2x to 2 sin x cos x, which is given here. So we get 2 sin x cos x square times cos x dx. And now we have 4 times the integral of sin square x cos cube x, and now we change the dx to du. So dx is 1 over cos x times du. And we have 4 times sin square x cos square x du. And cos square x can be written as 1 plus sin square x. So we can now sub u equals to sin x. So this will be u square times 1 plus u square. And now it will be 4 times the integral of u square plus u to the 4 du. And just integrate this part, which is u cubed over 3 plus u to the 5 over 5 plus c. And we need to sub back u equals to sin x. So we get 4/3 of sin to the 3x, sin cube x plus 4 over 5 sin to the 5x plus c. And we don't really need to find the c here because we are not given any values of x. For part C, it's a first order differential equation. So we can first we need to make sure that the equation given is in this format, where P and Q are just functions of x. So this is already in this form, so we don't have to rearrange it. So we can start by the first step to find the integral. So integral is basically e to the power of the integration of p. So p in this case would be tan x. So tan x is just sin x over cos x. And this would be ln cos x. So the final integral will be cos x. We don't have to care about the constant c. We don't have to write this here, only for this part. So second step, we let iy equals to the integral of iq dx. So I, in this case, is cos x times y, cos x times y equals to the integral of cos x, and q is sin square 2x. Sin square 2x. And we have actually done this in part B. The integral of sin square 2x cos x is this one. So we can copy this thing and paste it here. So we get y cos x equals to 4 over 3 sin cube x plus 4 over 5 sin to the power of 5x plus c. And now we use the values given here. Y equals to 4 when x is 0. So y equals to 4, x will be 0. Sin 0 is 0, so we don't have to care about these two terms. So c would be 4, because cos 0 is 1. You can type it into the calculator and check. So the equation would be, okay, we need to give the answer in the form of y equals fx. So y would be the subject. So we have to move the cos to this side. So we get 1 over cos x times 4 over 3 sin cube x plus 4 over 5 sin to the power of 5x plus 4. And to make it look nicer, we can change the 1 over cos to sec. So we get 4 sec x times 1 over 3 sin cube x plus 1 over 5 sin to the 5x plus 1. Question 7 is about matrix. So we need to find the matrix P and a diagonal matrix D such that the inverse of A is PD inverse P. So we will need to find the eigenvalues first. So if you see that a matrix has 3 zeros in the bottom left corner, like what I highlighted, then you can know that the ones in green are basically the eigenvalues of that matrix. So the first eigenvalue would be -6, second eigenvalue will be -2. Third eigenvalue will be 8. So now we need to find the eigenvectors corresponding to each eigenvalues. So we can write A minus lambda I, which for the first eigenvalue would be A plus 6i. This would be equal to 0, 2, 13, 0, 4, 5, and 0, 0, 14. So we can find the first eigenvector by just take any rows. Maybe we can take this times this cross vector with this, cross multiply with this, or this cross multiply with this. So I'm going to take this two. It looks easier. So 0, 4, 5 cross with 0, 0, 14. The answer would be 56, 0, 0. And we can take the 56 out. So the final eigenvector, the first eigenvector would be 1, 0, 0. For the second eigenvector, we get A plus 2i, which is equals to -4, 2, 13, 0, 0, 5, 0, 0, 10. But for this matrix, you can see that these two rows, you can actually simplify them to 0, 0, 1 and 0, 0, 1 if you divide this by 5 and divide this row by 10. So these two rows are actually multiples of each other. So if you decide to use this row, the last row can't be used. So you can either use this two or this two to get the eigenvector. So for the second eigenvector, I'll be using -4, 2, 13 cross with 0, 0, 5. And I will be getting 10, 20, and 0. Simplify the vector, and I'll get 1, 2, 0. For the third eigenvector, I will get A minus 8 identity. So it will be -14, 2, 13, 0, -10, 5, and 0, 0, 0. Similarly, when you get 0, 0, 0, you cannot really use this to find your eigenvector because all you will get is just 0 and it will not be helpful. So I will take -14, 2, 13 cross with 0, -10, 5. And I will get 140, 70, and 140. Simplify it, I will get 2, 1, 2. So P is just the combination of these three eigenvectors. So 1, 0, 0, 1, 2, 0, and 2, 1, 2. Okay, if your first eigenvalue is -6, your first eigenvector should be 1, 0, 0, and this should be put at the first column. Obviously, if you choose, let's say you choose 8 as your first eigenvalue, then you will have 2, 1, 2 as your first eigenvector. Then 2, 1, 2 should be put at the first column. Okay, so we just found P. And now we need to find D. Normally, when we have A equals to PD inverse P, this D would just be the first eigenvalue, second eigenvalue, and third eigenvalue placed in this format. Alright, but in this question is a bit special. We have inverse of A. So now, inverse of A is basically just P inverse of D and inverse of P. So this inverse of P is now your D. The inverse of D is now your D. So we can write it like this. D is the inverse of first eigenvalue is -6, second is -2, and the third one is 8. So D would be the inverse of this this matrix. And how do we find the inverse of this? If it's a diagonal matrix, we can find it by just flipping these three values. This only works in diagonal matrix, alright? Okay, similarly, if this is, let's say, D cubed, you can also just take -6 cubed, -2 cubed, and 8 cubed, like this. This is just extra info. Okay, now we can find that D is 1/6, 0, 0, 0, -1/2, 0. Sorry, this is -1/6, yeah? And the last row will be 0, 0, 1/8. This would be our diagonal matrix. Now we need to use the characteristic equation of A to find the inverse of A. So how do we find the characteristic equation? Basically, we use the eigenvalues. So we take lambda plus 6, lambda plus 2, and lambda minus 8. If it's a normal matrix, without this 3 being 0, this would be exactly how we find the eigenvalues, right? So now we just need to find the equation of that. So we expand the brackets. And we'll be getting lambda cubed minus 52 lambda minus 96 equals to 0. So we can change this equation. We can just sub lambda equals to A. So A cubed minus 52A minus 96I equals to 0. Remember to include the I here because everything here is a matrix, and if you don't put the I here, it doesn't make sense at all. It doesn't make sense for this two matrix to be minusing this random number here without the I. So we can divide this whole equation by A, so we get A squared minus 52I minus 96 A inverse equals to 0. And the inverse of A is basically just 1/96 times A squared minus 52I after rearranging the equation. So to find the inverse of A, we need A squared. We need to find A squared. So A squared is basically just -6, 2, 13, 0, -2, 5, 008 times itself. 0, -2, 5, 008. So same thing. To get the first number, we take this row times this column. So this times this, plus this times this, plus this times this. And we would get 36. For the second value, we take this row times this column. So we end up getting -16. The third value, we take this row times this column. And we get 36. For this value, we take this row times this column. And we get 0. Similarly, we get 4, 30, 0, 0, 64. So this will be a squared. So the inverse of a, we can now write it out in the matrix form. Minus 52i, which is just 52, 0, 0, 0, 52, 0, 0, 0, 52. So now, we just have to work it out ourselves. So 1 over 96 times. So basically we just take this minus this to get the first number, this minus this to get the second number, this minus this to get the third number, to get the whole matrix. So we get -16, -16, 36, 0, -48, 30, 0, 0, 12. And the final answer would be -1 over 6, -1 over 6, 3 over 8, 0, -half, 5 over 16, 0, 0, 1 over 8. This will be the answer for inverse of A. For question 8a, we need to state the sum of series of 1 plus z squared plus all this to z to the n minus 1. So it would be the first term times the ratio, and the number of terms is n. Take note that the number of terms is n, but not n minus 1, because this is z to the 0. So the number of terms is 1, 2, 3, and n. Okay? So there are n terms here. Minus 1 over the ratio minus 1. So we can simplify this to z to the n minus 1 over z minus 1. Okay, for part B, by letting z equals to cos theta plus I sine theta, we need to show this equation. So we can first write z to the n minus 1 over z minus 1 in terms of cos theta and sine theta. Let's write it smaller so we have more space later. Okay, so z is cos theta plus I sine theta n minus 1 and cos theta plus I sine theta minus 1. So we need to get rid of the imaginary number in the denominator so we can know which part we need to use. So we can first write this part as cos n theta plus I sine n theta minus 1 over cos theta plus I sine theta or minus 1. And like what I said, we need to get rid of the imaginary number. So we can actually times this part by cos theta minus 1 minus I sine theta. Okay, to make it clearer, let me rewrite this part. I can rewrite this to cos theta minus 1 plus I sine theta. So what we have to do here, how do we get this? It's basically we change the plus sign to a minus sign, and we will see the effects later. So now we can get, this will be a long one, we will get cos n theta cos theta minus cos n theta minus I sine theta cos n theta plus I sine n theta cos theta minus I sine n theta plus sine n theta sine theta minus cos theta plus 1 plus I sine theta. This will be the numerator. And for the denominator, we can use the difference in square. So we would get, we would actually get cos theta minus 1 square minus I square sine square theta. So we expand this, we get cos square theta minus 2 cos theta plus 1. I square is basically minus 1, so we get plus sine square theta. And we know that cos square theta plus sine square theta is equals to 1. So we can rewrite this thing. For the numerator, we can group the real numbers in one side and the imaginary numbers in another side. So we get cos n theta cos theta minus cos n theta minus cos theta plus 1 plus I times sine theta cos n theta plus sine n theta cos theta plus sine theta. Sorry, I forgot to add this. Okay. For the real part, we have another term which is sine n theta sine theta. Okay. And for the denominator, we can write it as 2 minus 2 cos theta. Like what I said, cos square plus sine square is 1. So this is what we'll get. n 1 plus cos plus 1 plus cos theta plus cos 2 theta plus 3 cos theta all the way to cos n minus 1 theta is actually just the real part of 1 plus z squared and all the way to z n minus 1. So, how do we know that? See, Zn is actually cos theta plus I sine theta to the power of n, and is equals to cos n theta plus I sine n theta. And that's why anything here, the cos, is actually just the real part of Zn, because sine is the imaginary part. So we know that 1 plus cos theta plus cos 2 theta all the way to cos n minus 1 theta is just the real part of 1 plus z squared all the way up to z to the n minus 1. And now we can just extract the real part. And this is why we need to get rid of the imaginary part of in the denominator just now. If the denominator is imaginary, how would we know which term to extract, right? So now that the denominator is real, we can confirm that if the numerator is also real, then the whole term is real. And when the denominator is real, but the numerator is imaginary, then this whole term will be imaginary. So we just have to extract this part. We just need this part. So it would be cos n theta cos theta minus cos n theta minus cos theta plus 1 plus sine n theta sine theta. And now we can rearrange it to, we can actually just take this term out. So we can rearrange this part into negative cos n theta times 1 minus cos theta plus 1 minus cos theta so we separate into two fractions. And we can get half of 1 minus cos theta times 1 minus cos n theta over 1 minus cos theta plus sine n theta sine theta over 1 minus cos theta. We're almost done. So now we have half of, see, we can cancel out this 2. So we have half of 1 minus cos n theta plus sine n theta sine theta over 1 minus cos theta. And this is exactly what the question wants. For part C, it's about integration and the sum of rectangles. So by considering the sum of the areas of this rectangle, show this inequality. So the rectangles are drawn here. So the width of each rectangle is 1 over n. And the height of each rectangle, you can see that for the first rectangle, the height is f0. Second rectangle is f1. Sorry, f1 over n. And for the third rectangle, we have the height of f2 over n. And so on and so forth until the last rectangle, we have the height of fn minus 1 over n. So now we can start doing. Oh, also, for the integral, we can see that integral is actually just the area of the graph, right? So the graph looks like this, and the area is basically just this part. And since that all the rectangles are a bit out from the curve, the sum of areas of these rectangles would definitely be more than the areas under the curve. So we know that the integral is definitely less than the sum of areas of those rectangles. So now we just need to calculate the sum of these areas. So we have, like what I said, the width of each rectangle is 1 over n. 1 over n times the height. The height of the first one is f0, which is 1, plus the second rectangle has a height of cos 1 over n. The third has the height of cos 2 over n, so on and so forth. And the last one would have the height of cos n minus 1 over n. And we can factorize the 1 over n out to get 1 plus cos 1 over n plus cos 2 over n until cos n minus 1 over n. Yes. And from the previous part, we know that the sum of this is this one. And we can just write theta equals to 1 over n, right? Because it's 1 plus cos 1 over n plus cos 2 over n, so on and so forth. So we can just change this theta to 1 over n. So we would just get 1 over 2 times 1 minus cos 1 plus sine 1 over n over 1 minus cos 1 over n. And this will be equals to 1 over 2n times 1 minus cos 1 plus sine 1 times sine n. sine 1 over n over 1 minus cos 1 over n. And we're done for part C. For part D, we need to find the lower bound for the integral. So lower bound means that the area of rectangles that we find has to be lower than the area below the graph. So we need to draw other rectangles. We cannot use this again. So what we do is we draw rectangles like this. So instead of having the height, the first rectangle like just now, we have the height of f0, right? So instead of that, we would now have the height of f1. Oops, sorry. And for the second rectangle, we would have the height of f2 over n. Sorry, this is 1 over n. Okay. Similarly, for the third one, you have the height of f3 over n. And for the last rectangle, we will have the height of f1. Okay. So the integral would now be more than the area of rectangles. Why? Because do you see these gaps here? These gaps over here? So the area under the graph will now be more than the sum of the areas of rectangles. So we can write this that the integral is more than, same thing, the width is 1 over n, and the height for the first rectangle would now be cos 1 over n plus 1 over n times cos 2 over n, so on and so forth. And we would have the second last rectangle as 1 over n times cos n minus 1 over n plus n over 1 times cos 1. Now this would be the area of the last rectangle. So same thing, we factorize 1 over n out, and we would get cos 1 over n plus cos 2 over n cos n minus 1 over n plus cos 1. And now you can see that this whole thing is basically this whole thing minus 1, right? So we can still sub this. So we get 1 over n times this thing minus 1 plus cos 1. Don't forget about this, right? This cos 1, yeah? So you would have 1 over n times negative half plus half cos 1 plus half sine 1 over n over 1 minus cos 1 over n. So this would be 1 over 2n times cos 1 minus 1 plus sine 1 over n over 1 minus cos 1 over n. And we are done. And this will be the last question for the paper.